Hello everyone, my name is Kevin Tarr. I'm an iOS engineer and today is day 21 of Algorithms in Swift. So today we're going to be dealing with decks, okay? Not like deck of cards. No, like real decks, okay? Uh, Double-ended queues that you can use to access items from the end of a collection type to the front of the collection type. Okay, and we're also going to be dealing with generics. Generics is a pretty advanced topic in Swift. I hope to cover it, and I hope that you guys can understand it because you will definitely need generics to be able to create a struct that could be used as a deck. So let's begin. So our problem states create a new data type that models a double-ended queue using generics or deck. You should be able to push items to the front or back, pop them from the front or back, and get the number of items. And we have our test example here, number array, number collection type, excuse me, that comes from a deck struct and is of integer type. We have pushback. We have the pushback functionality here. We have the popback functionality here, and some assertions. Okay, so basically we're going to create a struct. And we're going to do this in a pretty straightforward way. I think that this should be definitely comprehensible because we've been using a lot of these methods in some of the problems we solve. But creating a deck from scratch. Okay, so this should be interesting. Okay, so we're going to create a struct, and immediately we're going to make it of generic type. Okay, so this T right here means that this is a generic type, okay? What do generics mean? Generics are a way for a struct or a function to be completely type agnostic, okay? Type agnostic meaning that it doesn't conform to a specific type or it's not limited to a specific type, like a string or an integer or a double or a float. It is completely generic, for lack of a better term, to be able to be used on, be applied to multiple different types within Swift. So a good example of where generics could be really useful at are linked list, which could be applied to different types like strings and floats and integers and all those other data types. And a binary search tree could be really useful with generics and with deques because deques can be applied to any type. Like we can have a collection type of any type, so we need to keep it as generic as possible. Okay. So okay, so first we need to let's create an array first. We'll use array for this, and I want to make it of generic type, and we're going to call this a count integer, and we're going to return for a computed value the array count. Okay. Then we're going to create some mutating functions here. Now, mutating functions. So by default, just to make things safe for Swift, Swift automatically creates structures as constants rather than well, they create them as constants just to just to be safe. So meaning that functions by default aren't allowed to change the properties or the values of the properties that are inside the struct. If you want to explicitly change, if you want to change a value or change a property inside of a struct, you have to create a mutating function. If you want to change any property that is within the struct. So that's why we have to write mutating func rather than func here because we're going to be changing the array. We're going to be popping front, popping back, pushing back, pushing front. Okay. So let's do push front here first. Okay. We're going to do array. We're going to return. No, we don't need to return. We're going to array. Oops, sorry, forgot to insert the parameter here. It's going to be of generic type. And we're going to insert our object at 0. Okay? Then we're going to do push back. And we're going to pop the last here, okay? Oh, not pop last, sorry. Getting way too ahead of myself. I'm going to push back. So we're going to append OBJ, okay? Our append our object. We're going to append our object. Then we're going to pop back. Pop. Like we just tried to do just now. And we're going to return a nil optional generic just in case we don't have any anything to return in here. And we're going to pop the back of our array, pop last. In fact, I don't think we even need these parameters here. Just call it pop back. Then we're going to pop the front as well. And the pop front is the most fascinating part of this very non-exciting structured build, is because it requires an if statement. So we're going to check if the array even has a first, if the first is nil. If the first is nil, then we're going to return nil. And if it's not nil, then we're going to return array.first, force unwrap it. You can also do it if array is empty as well, just to see if it even has a count, or even do count if array.count is greater than 0. But I just want to do first just to be different and switch it up. Okay, so this should work here. If we were to create, much like here, right? If we were to create a numbers array here, okay, and then if we were to do something like numbers, we run one of our functions like numbers pop back. Oh no, numbers push back. Let's do 4, 5, and 6. Okay, let's push back 6. Let's push back 5. Let's do this in order. Let's push back 4. Let's push back 5, and let's push back 6. Okay, and then we were to pop the back of that, which would be taking away 6. We should be able to print out numbers, and should give us just 4 and 5 because we popped back the 6. Yep. And then if we were to further go forward and pop out the front of this array and print out the numbers, we should just get 4. We should get 5 because 4 is the beginning of the array. Okay. Oh, sorry. Array dot remove first. Sorry, I forgot to do that. Apologize. Yep. And if we were to do something else like numbers push front and add like 1 here, that should give us 1, 5. Right? And if we were to, which one have I not used? Push back, push front, pop back, pop. I've used all of them, okay? But let's just pop the back. Let's continue to pop it back until we have nothing here left. So numbers dot pop back. I think this should print out an empty array. Yep, empty array. Empty out the 1 and the 5. I'll pop in the back. So guys, this is a deque struct right here that we created. You could definitely be asked this in an interview to do this. Let me know what you guys think of this solution. If you have any other modified solutions or anything that could make this solution even fancier and better, I'd love to hear about it. I'd love to see it. But thank you guys for watching. Enjoy your Friday night. Have a good day.